Hello, everyone. Today, we are going to delve into a topic in fluid mechanics, the flow measurement using a rectangular weir. Here's our problem statement. We need to determine the height of a rectangular weir with a length of 6 meters to be built across a rectangular channel. The maximum depth of water on the upstream side of the weir is 1.8 meters, and the discharge is 2,000 liters per second. We are given a discharge coefficient of 0.6, and we will neglect end contractions. Before we dive into solving the problem, let's understand the concept. A weir is a barrier across a river or stream that alters the flow characteristics of water. It typically allows water to flow over its top, creating a controlled flow and measuring the flow rate. Based on the illustration, which is a rectangular weir, the height of the weir determines how much water can pass over it, given a certain depth of water upstream, while the length is the width of the opening through which water flows. To determine the height of the weir, we will use the discharge equation for a rectangular weir. Q equals 2/3 times C sub D times L times the square root of 2 times G times H raised to the power of 3/2. Where Q is the discharge, C sub D is the discharge coefficient, L is the length of the weir, G is the acceleration due to gravity, and H is the height of the water above the crest. First, here's a diagram to help visualize the problem. In the diagram, we have H sub 1, the maximum depth of water on the upstream side of the weir, which is 1.8 meters. H sub 2 is the height of the weir that we need to determine, and H is the height of the water above the crest of the weir. So, the given values are the length of the weir is 6 meters, the depth of water on the upstream side is 1.8 meters, and the given discharge is 2,000 liters per second, which we will convert to cubic meters per second. Since 1 liter is equivalent to 1,000th cubic meters, the discharge is calculated as 2,000 liters per second multiplied by 1,000th cubic meters per liter, which equals 2 cubic meters per second. Next, the discharge coefficient is equal to 0.6. Lastly, the acceleration due to gravity is 9.81 meters per second squared. Now, let's solve the problem using this equation. In our problem, the discharge is given with known values, so we can easily find the corresponding height. By substituting the given values into the equation, we have 2 cubic meters per second equals 2/3 times 0.6 times 6 meters times the square root of 2 times 9.81 meters per second squared times H raised to the power of 3/2. And to solve this, we get 0.328 thousandths meters. Next, to find the height of the weir crest above the water's surface, we will deduct our answer to the maximum depth of water on the upstream side of the weir, which is 1.8 meters. So, the result is 1.472 thousandths meters, and that's our final answer to our problem. Thank you all for watching. See you next time.